So in the spirit of Mother's Day and my topic this evening, I showed this video to provoke you to think about work differently. Work is becoming more and more unconventional. Are you thinking about it that way? I really appreciate the opportunity to be with you tonight, and I will now, after this fabulous meal, so my thanks to those sponsors who helped pay for it and the man who got the fish, that was so good, I will try and endeavor to provide you food for thought as we look into the future, which seems so appropriate as you look forward to the next 50 years and the 21st century golden spike. So I'll invite you tonight to come with me on a journey to consider the future of work. So the 30 seconds on GE, for those that don't know, just because it provides a little context for some of my examples. We're a global company. We're focused on technology and innovation. That's what we do. And we do it in a number of sectors: oil, gas, energy, power generation, transmission, distribution, transportation, we like planes and trains, and also healthcare. We research, we commercialize, we design, we develop, we manufacture, we service, we sell. And it's from that perspective that we see a world that is changing dramatically and on many dimensions. We do that in 170 countries. And what we see when we look around the world are a few things. Slower growth than expected in many developed countries. Burgeoning middle classes, especially in emerging markets, who are demanding a better quality of life, your quality of life. Unrest, concurrent with that, caused by currently high youth unemployment, underemployment, and lost generations in some countries who will not see employment. And everywhere, there is increased volatility. Whether you're talking about markets, let's just think about the price of oil these days, government volatility, Alberta, Quebec, the UK, Ukraine, or the climate. I was in Calgary on Tuesday and it snowed. Yeah. We also have social media. Social media redefining public engagement in a way like we haven't seen before and changing the role of what we used to call a regulator. And the consumer internet, creating many, many new disruptive business models. Track your ancestry, map your DNA, stay with me on Airbnb or hitch a ride with Uber. All incredibly disruptive, every one of those areas. But amidst all this volatility, we're seeing an equally, if not even more profound revolution underway, and that is impacting the future of work. And I thought I'd spend this evening giving you a glimpse of that. And we have just another video to draw your attention to.
The way we make things is changing, radically. A new set of ideas and trends have emerged and combined to create a new industrial revolution, one led by people and human innovation. This new workforce is more entrepreneurial, more creative. They're using ideas like collaborative design teams on a global scale, rapid prototyping, advanced materials, and leaner, more customizable manufacturing. Once upon a time, a factory made one thing, or a few things. Now, a factory can make almost as many things as there are people to imagine them. Which begs the question, if a factory can build itself, what else can it build?
There are three forceful drivers impacting the future of work that we see. And that's what I wanted to talk to you about tonight. One is the industrial internet, the Internet of Things that you hear so much about. The second is this whole area of advanced manufacturing. What does it really mean? What does it include? And the third is the emergence of the global brain. No one in this room tonight, and I know we have a mixture of leaders from many aspects of business institutions, government, no one will be immune from these forces of change and the disruption that they will create. So as organization, business, and community leaders, we need to understand these drivers, and more importantly, we need to be thinking now and anticipating their impact so we're ready. So first, let's talk about the industrial internet, the Internet of Things. How many of you feel you get it? You really understand what it's about? I know the lights are bright, but I'm not seeing any hands. Well, this isn't surprising. We have a survey called the GE Innovation Barometer. We surveyed 26 countries, and in 2014, we asked them about the industrial internet, was one of the questions. In 2014, Canada was at the bottom of the pack when it came to an understanding of and investment in the industrial internet. Others get it. Others are thinking about it. The industrial internet is really this idea. Think about the consumer internet. Think how much it has changed the way you shop, you research, you Wikipedia instead of encyclopedia. So think about that. Now go into the industrial side. The industrial internet is the integration of what is cloud-based analytics with industrial machinery. Some would say it's about big data connecting big iron. It becomes the internet of things, of stuff, of big iron, of machines. That's what we're talking about when we talk about the industrial internet. We can now collect and process tremendous amounts of data that was previously prohibitive. Why is that? There are 3 reasons. First of all, over the past decade or more, there's been an incredible change in sensing technology. The ability to sense, read, diagnose, collect information in machines and elsewhere. The second is that there has been a concurrent increased rate of speed of data processing, right? We all hear about those examples of the size of the computer that took the man to the moon is now in your laptop today, and in fact, way more than that. And the third thing is all that processing is coming at much lower costs. So we can now sense what things are doing in ways we couldn't do it. We can process reams of data in a really fast time period that we just couldn't do 2 decades ago. And we can do it really cheaply. The result is that machines can now become predictive, reactive, and even social. They can communicate seamlessly with each other and with us. Using advanced analytics, right? Crunching through these huge amounts of data, new data, fast and cheaply, the machines and the operators can now draw new insights that significantly increase our productivity, our knowledge, our efficiency. So machines like gas turbines, jet engines, locomotives, medical devices are becoming predictive, allowing us to actually fix them before they break. In other words, you can have 0 planned downtime. Let me give you some examples. Jet engines. We like jet engines. No doubt some of you in this room have at one time or another, this is just a guess, but I would guess that you have experienced a flight delay or a cancellation. Maybe. Did you know that 10% of those are caused by unscheduled maintenance? Something broke, they didn't plan en route, you are now delayed or not going anywhere. These unscheduled events in the US alone cost airlines about $8 billion. With new self-learning sensing technology, we can actually are moving to predictive maintenance, where the plane en route talks to the tech folks on the ground, and the issue can be addressed before the problem actually occurs. We know the plane doesn't feel good before it actually gets sick. In the US alone, that will prevent over 60,000 delays and cancellations in 1 year. Huge. Let's give you another example. Wind. We like wind. This idea of machines talking to one another comes alive for me when I look at the advances taking place in the renewable space, especially around wind turbines. Remote sensing, monitoring, diagnostics enable wind turbines to actually communicate with each other, and they adjust the pitch of their blades as the wind is coming through, because the guy over there sends a signal to the guys over here that says, the wind is coming from my direction, readjust. Think of the efficiency that that now delivers to a wind farm, because previously the wind had to hit that blade before it would adjust. Now you have time, so by the time the wind gets to you, you are in place and you are in position. This has helped reduce electricity generation cost in a wind farm to less than 5 cents a kilowatt hour. 10 years ago, that cost was over 30 cents, 6 times as much. That is what we mean by the industrial internet. Machines, data, predictive, reactive, and social. So what's the second force that we talked about? And that's the way we make things. It's changing. It is really changing big time. At the core of advanced manufacturing idea is this ability to digitally link together design, product engineering, manufacturing, your supply chain, your distributors, and servicing, all into one cohesive intelligence system, which we're calling the Brilliant Factory, an aspect of which you saw in the video. We've just opened our first effort in this area in a new flexible factory in Pune, India. This one factory, besides making jet engines and locomotive technology, is also going to assemble wind turbines and build water treatment units. The new design offers maximum flexibility. Imagine a plant, for those of you that are in that space, having all your lines and your supply chain set up for a locomotive production run in January and shifting over to wind turbines in February and water treatment in March. This is the first application of our Brilliant Factory concept, where the factory equipment and the computers are talking not only to each other over the industrial internet in real time, but they're sharing information and making decisions that ultimately preserve quality and prevent downtime. Of course, the other area that we are seeing significant change in production is all around the techniques that we're using. Robotics, artificial intelligence, and additive manufacturing. And I was so glad you got a taste of it for those of you that saw the machines doing the 3D printing, because these are things we hear about, and here's an example of 3D printing, which of course has emerged into something now called additive manufacturing, which is even next generation. As I have learned more about this process, which by the way has been evolving actually for over 2 decades, there are a few sort of interesting points that I think we should know. What's really interesting about additive manufacturing, 3D printing, just look at it out there. It went by a picture. It allows you to create totally new parts, new products with new properties, Right now, so much of what we make, it's designed around the way in which we have to make it, because manufacturing is limited in terms of how it produces stuff. You have to fit into machine tools. You're limited by the processes that are available to make stuff. So when you design a part, you're limited by the parameters in how you think about making that part, because you know you have to eventually have it machine tooled or worked in a plant. With additive manufacturing, you're free of that. You actually can design from a blank sheet, 3D, and design the part without necessarily thinking, in our case where we do a lot of metal, right, a lot of machining, about the capacity, the capability of machine tools and dies and the process itself to make this. You have all these new degrees of freedom that you've never had before to design a piece. With 3D printing, you have even more flexibility as well to produce the prototypes faster and at a lower cost. So engineers can actually print a part, test it, and based on the test feedback, you can actually quickly adjust the design, go back, and reprint it. You couldn't do that if you had to kind of push it through your system, change your manufacturing process, think of the time. Now, all of a sudden, you're using the same additive manufacturing machine to test all these different permutations. It hugely accelerates the cycle of design, prototyping, and eventually production. And that's just a few of the many, many attributes that additive manufacturing brings to the workforce. Additive manufacturing can now be used to build everything from shoes to medical implants to industrial components like parts for airplanes and perhaps even one day human tissue and organs. Aviation, which is interesting because when you think of sort of one of the industries that probably has the toughest tolerances, right? Zero defects of everything, right, is aviation. Just last month, the FAA approved the first 3D printed part to be used in a commercial aircraft. It's a metal casing, it's housing a temperature sensor, and it goes inside, it's our part going inside of our jet engines. GE is currently working with Boeing to retrofit more than 400 jet engines, some of the world's largest and most powerful, with this 3D printed part. Ultimately, additive manufacturing allows engineers to replace what might be complex assemblies with actually a single part that prints or creates the whole assembly. Lighter than previous designs because of the technology you can use and the materials technology that's now evolving to support additive manufacturing. And thus, for example, in the jet engine, we're saving huge amounts of weight, and in this case, boosting the jet engine's fuel efficiently tremendously. So that was the second sort of force that's changing. The third dynamic influencing how we work, we fondly call the global brain. How many of you have a significant problem in your business that you or one of your team is really wrestling with? You're stuck. How are you engaging the talent that is out there to help you? This is all about the collective intelligence that we can tap into around the world because of the availability of integrated digital communication networks. There are open source platforms, crowdsourcing, just two examples. We can reach a distributed global talent pool and engage their creativity and passion to solve that problem that your team is wrestling with. It's there, it's accessible, and the tools are there to do it. Why don't we do more of it? One of the best examples, and it was one of our first at GE, so I'll go back to it again, and I'm sorry I'm talking a little bit about aviation tonight, but I'll bring in some other examples, because we're doing it in other places too. But we had in aviation, it's an engine bracket. It holds the jet engine. Kind of an important part. and it's very heavy. And so we launched a design quest, we called it, where we challenged innovators around the world, open competition, to redesign the loading bracket using 3D printing. We made it open to the world, available, got it out. 700 entries came in from over 56 countries. The top 10 designs were actually produced at GE's Aviation's, our additive manufacturing facility in Cincinnati. We tested the resulting products, rigorous load testing at the Global Research Center. We actually found a winning design. It met all the requirements and reduced the weight of the bracket that we had by 84%. 84%. The creator wasn't even an engineer, nor were they even in the aviation industry. That translates into huge fuel, cost, and emission savings. Good for industry, good for the environment, a great solution. We reached out to the global brain, a call with a problem, and people came in and solved the problem. Another great example just here in Canada. We want to reduce GHG emissions in the oil sands, right? Important. So we launched a global challenge to help us do that. We worked with COSIA, the Canadian Alliance of Oil Sands Companies that was formed, 14 oil sands companies. They helped us with defining where were some very particular areas where they felt if we could get some solutions, it would significantly reduce emissions. And so we went out and we said, okay, let's launch a 1-2 phase, a 2-phase quest, again, challenge, attract these global brains to our problem here in Alberta, and let's try and address this environmental challenge. The phases generated 64 applications from across the world. Unlike the other one, which was a little broader, we were very, very specific. We tried a different approach here. Phase 1 ended up with 4 winners. From India, Netherlands, England, and Italy. None of the applicants and winners had ever even been to the oil sands. GE is working on development agreements now with these guys to actually design and now test the proof of concept into real applications. Pretty cool, huh? Pretty exciting. You know, the future of work is changing. And these 3 forceful market dynamics are driving huge disruption. The industrial internet, driven by this idea of big data, connecting, talking with big iron, the way we make stuff, robotics, artificial intelligence, additive manufacturing, and this whole connected human network, where people will be wanting to work on the things that use their design, use their creativity, and in many cases, robots and other forms of new technology will be taking some of those jobs while humans redirect to the next level of design, creation, and innovation. As these changes gain momentum, we are going to see many more disruptive business models emerging. It's not like one day it's here and the next day it's gone. They are coming in now. These things are happening now. And one thing we've learned from folks like Ray Kurzweil and the University of Singularity down in California is right. This innovation starts quietly and slowly, but then it actually builds and grows exponentially. And if you're not ready for it, you are left behind, because when you finally start to really hear about it, it is moving so fast. If you haven't been playing on the fringe, experimenting with it, you will miss it, and it's very hard to catch up. In these models that we see, you can have manufacturing and services actually converging. You're going to have manufacturers who are actually embedding more and more software into their products. GE, you think of us as a hardware company, those of you that know us, where we make the stuff. We are now one of the largest software companies in the world and getting bigger all the time because all that stuff is now being driven by analytics and software. It already had it in it, but now it's a whole new round of what we're able to do and the data we're able to collect. And so while we're embedding more software into our products, we're upgrading. The upgrades won't be hardware upgrades anymore. What we'll actually be doing is service updates to the software that changes the functionality of that hardware. On the other hand, we've got service companies like Google and Amazon who are actually turning into custom manufacturers. Think of 3D printing, what it does in terms of distributed manufacturing. Amazon can start to say exactly what color, what da-da-da-da do you want, and we'll just print it right here and get it to you if they want to. So we'll see this whole level of distributed customization that we just haven't seen before. And the technology is here and the capability is here today, now, to do this. We are doing it, others are doing it. Are we doing it fast enough, and are you doing it? You know, the factory and the field are going to become digitally interconnected in real time and 3D. For example, the same is going to happen with the factory and supply chain. The collaboration between parties is really going to change because it might drive a rethinking of the business and the economic models different from what we have today when you think of the traditional connection. You're my supplier. Well, if everybody's talking and if they're predicting what you're going to do, is it the same economic model that we used to have? Are the software models with customers the same? What does that look like? You know, I currently sit, a lot of you might be saying, this is really interesting, thank God I'm not in manufacturing. But I hate to tell you, you're not immune. You know, I'm on the board of governors for the ROM. And we've been that's the Royal Ontario Museum in Toronto. And you know, our last field trip down to the States to see the Smithsonian, we focused on how does digitization, that's a hard one, how does that and additive printing, global connectedness actually change the traditional model of a museum from the perspective of the admin team, from the perspective of the curator. Suddenly, are we having to, how do we make those bones? Are we using casts? Can we scan it in the field? Can we make a 3D image? Do we actually have to have the real stuff on the floor? Or can we put additive printed examples out there so we can actually be better preserving the original bones? What about digitizing records? What about things that might need preservation and it's really difficult, it's really expensive? What if you can scan it, recreate it? How does that apply? How do you think about that? I was also at a board of directors last week for my university, business school, and we were supposed to have 6 groups. We were talking about the residential experience, the new curriculum, technology, and there were 3 other groups. We all came back for the plenary. Every group talked about technology. And how was technology fundamentally going to change the way we thought about the delivery of education, the cost of education, the business model of education, using, again, digitization, global connectedness, data analytics to process stuff. What did that start to look like? Are you ready? Are you, in whatever organization you're involved in, are you thinking about these sorts of disruptors and how they could influence the future of your work, your company's work, your organization's work? So let me close with a few suggestions of maybe what can we all do as business, community, organization leaders in Canada to make ourselves strong, our organizations ready, and by virtue, make our country stronger. First of all, we have to invest in new technology. Innovation happens at the fringes. By the time we all know about it, something has taken off. If you were there, you're riding it and you're in great shape. If you missed it, you're going to be running like heck. How do you play in this space? You've got to pilot, you've got to test, we have to be. making investments. You know, I talk to, when I, go to many speeches of, GE leaders, and the one thing many of them have learned in their experience, those that have had a lot of experience with the company, is never stop investing in innovation and technology. Because when we did it, especially during bad times, a couple of years later, when the times are good, you have that hiccup where you don't have what you need because you had that pause a few years earlier, and somebody else in the competition didn't pause, and now they're ahead. We just can't stop investing. And it doesn't mean going whole hog at it. It can be testing, piloting, just making sure that you're familiar with it, that you understand what the industrial internet is about, that this isn't the first time you saw a 3D printer, because maybe you've got one sitting so that all your employees see what it is too and understand and think about how it could maybe change your business to be more productive. Digitization, 3D printing, robotics, we all have to be playing, testing, investing. The second is think about your own practices as an organization. The factory of the future, the way that will affect our deal structure with customers, our compensation and training with employees. We have to encourage much more collaboration and entrepreneurship within our organizations and with our partners. Again, as a way to get the access to new technology, that's a great way, but also to think about, okay, if this happens, how does it change the way I do my work? If the curator isn't really curating in the same way anymore, what does that mean in terms of the definition of the next generation that we want to hire? What are the skills and competencies? Another area that I find fascinating, and it's particularly acute today, and this is the whole area of cybersecurity. As we build all this industrial internet, embed much more sensing, technology, software into our stuff, how are we going to protect that? Are you protecting it? Do you know where you're vulnerable today? We have to protect sensitive information, intellectual property, safeguard critical infrastructure from cyber attacks, which are increasing all the time. And I'm really excited about it, especially today, because today I was here visiting a Vancouver company that GE just purchased. That's one of the world leaders in cybersecurity, called WorldTech. And a lot of us think about enterprise risk. But what we forget is that within the enterprise, there are all these machines. Hacking can happen at that distributed level, not just at the enterprise level. How are you protecting your machines, your stuff, your local computers, your local, we think enterprise, we don't think the operational technology. And that's where we're focusing. And as I said, we're really delighted that WorldTech, who some of the guys are here tonight, and I've been sending a lot of you over to go talk to them because I spent the day with them. And I tell you, it is cool. It's frightening what they showed me in terms of how vulnerable we are. And it's really cool to see where we can go in terms of being able to think about this, protect ourselves, and that way actually invest and grow, but not make ourselves more vulnerable in doing so. There are ways to protect this. And then think of all this, and I had the pleasure of speaking with a gentleman from Vancouver University, Ralph, I think it was, if I got that right, and the whole implications of all this for our education system, for our workers, for our leaders, our managers, how much we're going to have to evolve to ensure that students are equipped with the right skills. My Bromont manufacturing plant, we have 800 people there. We make aviation parts in Bromont, Quebec. Our most productive plant in the world in the GE aviation system is in Canada, in Quebec. Over the past 5 years, we added 100 robots to that plant. Not one person whose jobs the robot took was laid off. All the people who were doing that work helped to train and translate how that work was done to the software developer and architects who in fact then had to do the robotic programming. But the skills now that we need in our aviation plant for that next generation of people we're hiring are very, very different. They're operating with the robot. They're a team with a cell of robots, leading it, designing, showing how to progress and get more efficiency. Huge, wonderful, fantastic jobs. It is very different than what we were hiring there 2 decades ago. Are we pushing and thinking about the next generation of workers and training them to be data scientists, software developers, programmers, and understanding this software world? And of course, for the many of us that are in the workforce today, how do we cushion the impact of transitional disruptions in the labor market? What are we doing in terms of new skills training, programming, as I said, programming training, learning development, and increasing kind of the learning opportunities for our workforce so that they're not caught behind either. Just as you're experimenting with new technologies, how are you helping your workforce to be current with this stuff, to be excited about it, not afraid of it, and actually to be thinking about how to integrate it into your business? So let me just conclude by saying, the future of work is very real. It is happening now. It is changing around us every day. We're seeing many examples of how work is fundamentally being disrupted and being renewed. And it's very exciting. And no one has all the answers. At GE, we say, it's a figure-it-out world. We can't expect to have all the answers, but we know that it's happening. And if we're not engaged with it, open to it, seeking it out and embracing us, we will miss it. And so as you think about the next 50 years, I hope I've given you some perspective, provoked your thinking a little bit about what are some of the issues that you as the Business Council and business and community leaders will need to be thinking about so that BC and Canada will continue to be global leaders. Thanks so much for your time, and I look forward to the discussion and questions.